Okay, I'll be submitting a new link for you to submit your lab report through Webble. Okay, now for this experiment, for this subject, you have two experiments. The first experiment is a fatigue test. All right, the first experiment is fatigue test, and for your next session, I'll be discussing with you annealing process. Okay, annealing. All right, now let's stick to fatigue test first. Now, fatigue test is a form of failure when you have a repetitive or cyclic stress along your object. Okay, the keyword is cyclic stress along the axis. You can be parallel or perpendicular to the object. Okay, so the cyclic stress would cause stress over time in a repetitive manner. Okay, that's what I can give you a definition for cyclic stress. Stress over time in a repetitive manner until the object fails. All right. So to simulate fatigue tests, we have a lab equipment in level 7, which can be viewed in the video slideshow over here. Okay. Somewhere over here. We'll watch the video and I'll explain to you one by one. All right. So for this fatigue failure tester, we have a load nut number 1, and we have the speed controller. We have the dyno over here. Dyno, it is dyno, and we have the limit switch cut off. All right. So what students should supposed to do is they should equip themselves with, where is it? Okay, brass specimen and also copper specimen. Please take note, we are not using aluminum specimen. Okay, we are using copper specimen and also brass specimen. Okay, so let's watch the video. I'll explain to you in depth what is this experiment is all about. Okay, now. So this is a fatigue test. So we need to have aluminum, and this is the test setup. This is the test setup. The first step is you need to measure the length of copper and brass specimen. So this is copper and this is brass. Okay, you need to write down the initial length. All the values I've given in Webble. You can have a look in Webble. Take the length. Next step is to measure the smallest diameter, which is the center of your specimen. Okay, here again I'm repeating the same procedure again. So you have two specimens. The first specimen is copper, the second specimen is brass. The first step is to take the length of each specimen and then the smallest diameter of your specimen. Obviously the smallest diameter is in the center of your specimen. Okay, and this is your setup. Okay, this is your load nut. Okay, this is your load nut, and this is your balance. This is where you set the load. And this is your dyno motor. This is the shaft. Inverter speed controller. I'm going to use brass sample. I'm going to use brass sample. All right, you need to insert the brass on the shaft and lock it. Make sure it is perpendicular to the balance. You need to use the lock to fasten it. Okay, it is okay now. Okay, once you have fastened it, make sure. Okay, once you have fastened it, make sure this specimen is parallel to the shaft and perpendicular to the balance. Okay, now guys, as I mentioned to you earlier, fatigue test, right? Fatigue test is a cyclic stress exerted to the object, right? So your cyclic stress is being generated by the dyno, by the shaft. So it will keep on rotating, creating a cyclic stress where you will exert a load on this balance. Okay, so that is fatigue test. Here you will set your load according to the lab sheet. You can set your load according to the lab sheet. For copper specimen, you have 8, 10, and 12 kilo. For brass specimen, you have 12, 16, and 20 kilo. Set the load accordingly. So for this experiment, I'm going to test with 20 kilogram. Tighten, tighten your specimen. Okay, now once you have tightened, you need to make sure that all the keys, the point is in the center. Okay, you just need to leave a free space of 3 mm. Okay, once everything is okay, I'll set the load for 20 kilograms. So there will be a load of 20 kilogram in this direction. Constantly pressing the specimen which is rotating. So that is cyclic stress. Okay, to run the experiment, the first step is to turn on the mains, and this is the RPM. This is the counter. Okay, this is the most important part. Okay, that counter shows at what count does this material breaks or snaps. Okay, I'm repeating again. So this counter here stops counting when the material snaps or break. Okay, so you need to take this counter as the turn, as the number of turn before the material snaps or break. This is the protective cover. It will break with a huge release of sound and stress. Switch on, make sure the counter is 0, and you can rotate that knob to maximum rotation, and it will snap anytime now. snaps. Okay. All right. I'm repeating this again. Rotate the knob, maximum speed, rotates and it snaps and it moves upward. Okay, can you see? Once it moves upward, it means that 20 kilo. This is the force I've given for the object at 20 kilograms. So the amount of stress is huge. That's the reason why it snaps very fast. Okay, if I test for 10 kilo or 5 kilo, it might take about 5 minutes to 10 minutes to snap. Okay, so this is the count the material have gone through before it snaps. Okay, then after that you set it to 0, turn the knob back to 0, switch off the mains, remove the material. Repeat the same procedure for 12 kilo, 16 kilo for brass, 8, 10 and 12 for copper specimen. This is the damaged material for brass, which is load as 20 kilogram. Okay, guys. So can you understand this experiment? Can you understand? Any questions from the video for clarification? Any questions from the video, guys? All right. Okay, that's good. So, any questions you'd like to ask? Perfect. Now, guys, so that is fatigue. That is fatigue. So fatigue, essentially, if you look at the lab sheet, fatigue is a form of failure that occurs in a structural subjected to dynamic or fluctuating stress. Okay, repetitive or cyclic stress. All right. So fatigue would eventually fails the material due to the repetitive stress. So if you look at your lab sheet, all right, in your discussion, it has asked several questions, right? Explain fatigue, then discuss the increase of magnitude of the applied stress affects the number of cycles to failure for both samples. And then it asks you to determine the fatigue strength of copper at 3 times 10 to the power of 4 cycles. And then it asks you to determine the fatigue life NF for the brass of applied stress level of 50. So there's some calculation involved, right? Now, if you could open up your practical fatigue experiment use. So I've given you some values, all right? Can you look at the screen? Okay, you can't see my screen. Okay, something is wrong actually. Okay, how about now? Can you look at my screen? Okay, yeah, I think the internet is very poor. Anyway, okay, good now. So I've given you the values. I've run the experiment for you. Supposedly you should do the experiment, but since will be having all virtual, so I need to run the experiment and I got those values here. So I've used 10 kilo, 12 kilo and 14 kilo, and this is the measured diameter and length. For brass, I've used 16 kilo, 20 kilo and 24 kilo. And this is the measured diameter and length. And N is the number of counts. For 10 kilo, the material rotates 1420 rotation before it snaps. For 12 kilo, the specimen rotates 140 counts. For 14 kilo, the material or the specimen rotates just 125 rotation. So when the load increases, the rotation decreases. Same goes here. When the load increases, the rotation decreases. All right. So I want you to write down a report on the relationship of load and this what they call that rotation based on the questions posed on your lab sheet. Find the maximum bending stress amplitude. Okay, find the maximum bending stress amplitude based on the lab sheet, and then hold on, okay, here you go. Okay. All right, so you need to find the maximum bending stress amplitude, and then you need to draw a graph of stress versus log number of cycles to failure. All right, stress versus log number to cycles of failure for both material. Okay, one is for brass and another one is for copper. So you need to log all your, where is it, all the values of n, so that you can plot a graph of stress. You need to find the stress, which is this maximum bending stress amplitude over log number of cycles to failure. Then you can answer all the questions listed in the end of your lab sheet. Then you can determine the fatigue strength copper at this, and also what they call that fatigue life of brass at the applied stress level of 50 megapascals. All right, so you need to extrapolate your graph. Find the relationship between two graphs. Find the equation for this graph. Extrapolate your graph based on the questions posed here. Okay, guys. All right, any questions? Any questions, guys? The graph title, okay, the graph title is supposed to be graph of stress versus log of cycles. Graph of stress versus log of cycle here. This is the title of the graph. Okay. Yes, okay. As for the submission due date will be next week, Monday, before 12 midnight. Okay, next week, Monday. So I'll be closing the verbal submission at 11:59 night on Monday. Okay, submission Monday next week. Where is it? Next week, Monday will be 6th. Okay, 6-page maximum excluded of front page and reference. Yes, excluded of front page and reference. But it says 6-page is maximum, right? I don't mind. Really don't mind on the number of pages. So you can have how many pages you want. I don't mind on that. Okay. All right. One more thing. One more important thing, guys. When you're writing your report, it is not necessary for you to copy paste the whole what they call that description. All right, the equipments, materials, item. It is not necessary at all. The procedures as well. I want you to write in a brief manner. Okay, write down the brief manner of these procedures, of this objective. Yes, there must be an objective, there must be an introduction on your lab report, but it is not necessary for you to copy and paste. Okay, so the aim as well. Okay, you can write the aim, but not necessary for you to copy and paste. So you can write in your own terms briefly enough. I'll be concentrating more on your questions, on your results and discussion. So write more in your results and discussion. So more marks will be given in your results and discussion. More pictures, more explanatory description. If you can give me your whole calculated results, more marks on that as well. Okay. And submit your report in Webble in Webble. Open the Webble link soon and submit in PDF format only. Okay. Your file name is very important. It must be your name underscore ID, experiment title, and then group. Okay. Cheng Tek Kai, can you hear clearly now? Cheng Tek Kai. Okay, good. So do you have any questions? Since just now you can't hear clearly, do you have any question? Would you like to ask any question? You can on your mic actually, since we have only 13 students. How come there are 13 students? Supposed to be 11 students. Is there anyone from different group? Is there anyone from different group? Anyone from different group? Just declare so that I can keep note of you for the attendance purpose. Anyone from different group? All of you from the same group. It is impossible. You know, supposed to have 11 students only for P2. Guys, come on. Anyone from different group? Okay. Cheng Tek Kai. So what group are you from? Okay, P3. All right, P3. Okay, you're from P3, huh? All right, Nicholas. Okay, now you are from P3. All right, please write your name and your group for those who are not from this group, so that I can keep track on that. This is for the attendance purpose, you know. Please write your name here in your chat box and your group. For those who are not belongs to this group, no problem. It's okay to join, no problem at all. Cheng Tek Kai, okay, I got it. Nicholas, you are P4, okay. All right, so only 2 students, right? Yeah. Okay, guys. Okay, yeah, I got it. Thanks. Okay, guys. Are you clear? Are you clear with the brief of this virtual experiment? Is the video clear enough for you, or do you need any other clarification?